Welcome to EDU World Space.
Chapter 4, problem number 37. We got three people pushing a cart. They want to push that cart straight in the positive x direction. One person's pushing at 100 newtons, 60 degrees above that, and the other person's pushing at 140 newtons, 30 degrees below that. And the third person needs to figure out what direction and how hard they need to push so that the cart goes in the positive x direction. What we're going to need to do is find the components of each of these forces. So F2 is going to have a horizontal component given by that blue line, and it's going to have a vertical component given by that blue line. And we can see that if we take the blue line that's going straight down and move it over here, we've got a right triangle. The vertical blue line, we'll call that F2 in the y direction, is the side opposite, and 140 newtons is the hypotenuse. So hypotenuse times the sine of 30, because opposite over hypotenuse is sine, remember. So this guy's going to be hypotenuse 140 times the sine of 30. And the sine of 30 is a half, so we're looking at 70 newtons going to the right. Similarly, we are going to use cosine for this guy right here, F2 in the x direction. That's the side adjacent. We have the hypotenuse. Adjacent over hypotenuse is cosine. So the hypotenuse times the cosine of the angle is going to give us that horizontal component. So that horizontal component works out to be 121.2 newtons. And we're going to do similar things up here to find the x component of F1 and the y component of F1. And again, the x component here is going to be cosine because it's the side adjacent 60. The y component is going to be sine because if you pick it up and move it over here, it completes the right triangle and gives us the side opposite. So putting those in, let's see here. We get 100 times the sine of 60 is going to be 86.6 newtons for our vertical component there, and 100 times the cosine of 60 is going to give us 50 newtons for the horizontal component there. So we already have two components going horizontally. We got 50 newtons and we got 121.2 newtons. So the third person doesn't need to push in the horizontal direction at all. The problem is we've got 70 newtons going down and we've got 86.6 newtons going up. So for this thing to not accelerate at all in the y direction, we need no net force in the y direction. So how much does the third person need to push with? They need to push straight down. Let's go purple, straight down right here at 16.6 newtons. That's all they need to do because they only want it to go in the positive x direction. So they counteract the 86.6 newtons and we have a total downward net force of 86.6 and upward net force of 86.6, and that's what the kid needs to do. So 16.6 newtons in the negative y direction. That's part A. Part B wants to know what the weight of this object is that they are pushing. They tell us that it accelerates in the positive x direction at 2.0 meters per second squared. Based on that, what is the weight of the box? So let's use our good friend Newton's second law. Net force in the x direction equals ma in the x direction. We've already pretty much figured out what the net force in the x direction is. We've got one component giving us 50 newtons. We got another component giving us 121.2 newtons. So the net force in the x direction is going to be 171.2. And we are going to plug in the acceleration to find the mass of the box. So we've got 171.2 divided by 2, and the mass of the box ends up being 85.6 kilograms. And you'd like to think you're done, but no. The question didn't want the mass of the box, the question wanted the weight of the box. And we always calculate the weight of the box by doing m times g. So multiply that 85.6 by our friend 9.8, and you're going to get about 839 newtons for the weight of the box, m times g. Always remember, mass and weight, two different things.